Hello everyone. So in the last class of COA, we solved some K-map problems using two variables, and I think only one we solved using three variables. So today we will solve all the K-maps using three variables. Okay. So here the problem is f of ABC is equal to summation of 3, 4, 6, 7. So I hope you remember how to draw the K-map of three variables. Okay. See, as usual, three variables means 2 raised to 3, that is nothing but 8. So 8 squares we have to draw. So here 8 squares I have drawn here, and this side only one variable and this side two variables. So as usual the values are 0 and 1. Next BC, 2-bit combination, 0 0 0 1 1 0 1 1. And why these two are exchanged, that I have explained in the last class. So now 0 1 2 3 4 5 6 7. Okay. So now which are the numbers given? 3 4 6 7. 3 4 6 7. Okay. Now we have to group these. Okay. Now looking at these two, can we pair these two? Yes, because they are adjacent to each other vertically. Therefore, this is one pair. And see here, we can pair these two. Instead of that, I tell you, this and this can be paired. As I told you in the last class, the ones at the end of the or at the terminal of the K-map can be paired. Therefore, this can be paired with this. So all the values are covered. Hence there are only two pairs. This one and this one. Okay. Now let us write the logical expression for this. See, for this horizontally nothing is common because it is varying. 0 is becoming 1 here. So nothing is common. Leave it. And here vertically, see, I hope you can understand this. See, there are two values. The first value is nothing but B, okay, and the second value is C. If it is 0, complement of that variable. If it is 1, that variable is self. Therefore, 0 0 means B bar C bar. 0 1 means B bar C. 1 1 B C. 1 0 B C bar. Okay. So now here vertically which is common? BC. Over. Next, about this. Horizontally 1 is common, nothing but A. Then see here vertically. Which is common here? This 0 is common, which is nothing but C bar. So the logical expression for this K-map is nothing but BC plus AC bar. Now, next one is 0 2 4 5 6. Okay. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, now the numbers are 0, 2, 4, 5, 6. 0, 2, 4, 5, 6. Okay, now this time, see here. These two and these two. these two can be paired right. These two can be paired right. But these two pairs are situated exactly at the terminal of the COA. Therefore, these two and these two together, it can make quad. Quad in the sense group of 4, which is nothing but called as a quad. Therefore, these 4 can be grouped. Okay, so these 4 together is one group now. Okay, now left is this value and this can be paired with this. Therefore, this is one pair. And as I told you, one value can be involved in more than one group also, because this value is involved in quad and this value is involved in pair. That can be done. Okay, so totally how many values we have? We have 5 values, and how many groups we have? Only 2 groups. So let us consider quad first. So for this quad, horizontally nothing is common, and here again C bar is common. So C bar plus for this pair here A and here is which is common B bar. So this is the logical expression. Okay, let us solve few more problems. One, 3, 5, 7. Okay, now see 1, 3, 5, 7. 1, 3, 5, 7. Now you tell me all these 4 values are adjacent to each other. Then should we pair them or should we make a quad? Okay, so when we have 2 options, it is better to make a quad. Okay, so that it makes only one group. Because see, if you can ask me the question that instead of making a quad, we can pair them. See, if we pair them, these two together one pair and these two together one pair. Yes, these two one pair and these two one pair. Okay, when we make 2 pairs, I mean 2 groups, we will be having 2 terms in our expression. Okay, if instead of that, if we make one quad, we will be having only one expression. So which is more simple? Either having 2 terms or 1 term. So 1 term is more simple. So we have to keep in mind that before writing the logical expression or before grouping the values, we have to keep in mind that we have to simplify the grouping as well as logical expression as much as possible. We have to simplify it. Okay. Therefore, instead of making 2 pairs, we can make 1 quad, which is more simple. So let us make 1 quad. Here nothing is common and here is this one is common. One is nothing but C. See, we got a very simple expression, that is C here. Okay. Next. Now the next one is 1, 2, 3, 5, 6, 7. Okay. See, 1, 2, 3, 5, 6, 7. Okay, now look at this. See here, totally we are having how many values? 6. And all 6 are adjacent to each other. Now you can ask me a question like, can we group all these 6? No, it is not possible, because if you make one group, okay, we have to find one common variable. Among three, we won't get anything as common. So the option is only this much, only a quad. So how many quads are possible now? See, if we make this as one quad, what about this? We can make it pair, but instead of making this pair, we can consider these two and make a quad. See, 2 quads we are having now. Okay, so now for this quad, horizontally nothing is common, and here C is common. C plus for this nothing is common, and here we have B. So the expression is C plus B or B plus C. Now the next one is 0, 1, 2, 3, 4, 5, 6, 7 means all. See in this, all the values are 1 here. Now what we in this case, as I told you, while using 2 variable K-mapper. Okay? If you remember in the last class, when all are ones, then what is the value? Because when all are ones, then we won't get any variable as common, of course. Therefore, the value will be 1. So, the same rule is applicable here also. Altogether one group, horizontally nothing is common, and vertically among 4 we won't get anything as common, hence the value is 1. The expression for this K-map is 1. You have to remember that it may be a K-map of 2 variable or 3 variable or 4 variable. Okay. So if all the squares are 1, I mean all the values are 1, that means the value of the K-map or the logical expression of the K-map will be only 1. Okay, now the next one is 0, 3, 4, 7. Now see, 0, 3, 4, 7, 0, 3, 4, 7. Okay, now tell me. Okay, so you can think that these 2 and these 2, can they may be paired? Of course they can be paired. Can they may become a quad? Can they become a quad? See, these 2 and these 2, they cannot be quad because they are neither adjacent to each other nor at the terminal of the K-map. Okay, so this one is exactly in the middle. This is not adjacent to each other or this is at the terminal. Okay, if you make quad, now look at this, horizontally nothing is common and vertically 0, 0, 1, 1 nothing is common. So this cannot be made as a quad. That you have to remember. To make a quad, one thing like this, they must be adjacent to each other. Yes, they must be at the terminal. I mean exactly at the end. If this is like this, this cannot be made as a quad. Okay, so now this is one pair, this is one pair. So totally we are having 2 groups here. So now for this, horizontally nothing is common and vertically B bar C bar. Plus for this, horizontally nothing is common and vertically BC. So what is this? B bar C bar plus BC. This is nothing but XOR gate. Okay. So we can write it as B XOR C. Okay. Of course, this is also correct answer. If you remember it, if you know it, you can write this expression also. Otherwise, only for this also you will get full marks. Now the next one is 0356. Okay, now 0356. 0, 3, 5, 6. Okay, now this is not so easy because we cannot pair them. Okay, see, this cannot be paired with this because they are not adjacent to each other, or they are at they are situated at the terminal of the cable. So we cannot pair these two. And this one, cross grouping is not there. Either they must be adjacent to each other horizontally or vertically. This is in the form of diagonal, which cannot be paired. What about these two? These two cannot be paired. Then what is the solution? All the four values are four groups. So we are totally having four groups. So we have to write expression for each value. See, for this, horizontally which is common? A bar. And here B bar C bar. See, we have to write all the values. Okay. Plus for this A, here B bar C. For this here A bar. Here B C. Plus for this here A. Here B C bar. So this is what we got. Now you have to think, can we simplify this expression? Of course, yes. Using Boolean identities and Boolean theorems, as we solved some Boolean expressions in previous classes. Okay, let us solve this also. Now, in these two, can we take common? Yes. B bar is common. Therefore, here A bar C bar plus here AC plus, in these two which is common? B, right? So B is common and here is A bar C plus here is A C bar. Now B bar. What is this? A bar C bar plus AC. This is nothing but XOR gate. Therefore it is A XOR B plus B into, what is this one? A bar C plus AC bar means XOR gate. Therefore it is A XOR C. Now look at this. A XOR C, A XOR C. Now let X equal to A XOR C. Let X equal to A XOR C. Then you just replace A XOR C by X here. What will be the expression? C. B bar. What is this? It is B bar X bar plus B X. Okay. So now, what is this expression? B bar X bar plus B X means B XOR X. So B XOR X. Now you put the value of X here. B. What is X here? A XOR C. A XOR C. Whole bar. Okay. So we can write this as A XOR B. A B C XOR it is. Okay. So this is how we can simplify the expression. Now the similar one will solve one more. That is 1247. Okay, now see 1, 2, 4, 7. Okay, so which is similar to the previous problem. Okay, so can we pair? No. Can we make a quad? No, it is not possible. Therefore, all the 4 values are individual groups now. So all are individual. We have to write the expression individually. So for this, here is A bar. Here B bar C plus this one A bar. Here is BC bar plus for this A B bar C bar. This one A B C. Okay, so this is the expression we got. Now we can simplify it further. Okay, so in these two, which is common here? A bar is common. B bar C plus BC bar plus. In these, which is common? A is common. This one B bar C bar BC. Okay. So now A bar into what is this B bar C plus BC bar? This is nothing but B XOR C. Therefore B XOR C plus A into what is this? B bar C bar plus BC means B XOR C. So B XOR C. As usual, let X is equal to B XOR C. Now let us put the value of B XOR C as X. A bar, what is this now? X. Plus A, what is this now? X bar. Now, what is A bar X plus A X bar? This is nothing but A XOR X. A XOR X. Now put the value of X. A XOR. What is X here? X is nothing but B XOR C. So the expression is A XOR B XOR C. In the previous problem, the final answer was XOR A B C XOR, and this time it is A XOR B XOR C. Okay, so I guess only these two are the cases where we need to simplify. Otherwise, we will get the direct simplified expressions. Now, let me give some homework problems for you. Okay, so these 5 are the homework problems for you. Okay, so whichever problems I have solved in the class, you practice them so that you will understand what are the rules, how to group the values, so that you can solve these 5 problems. Okay, and let me know your answers also. Okay, so in the next class will solve K-map using 4 variables. Okay, till then you practice K-map of using 2 variables as well as 3 variables. Okay, and try to solve these 5 homework problems and try to get correct answers. Okay, till then take care.